You really need the quadratic formula when things don't factor, or you can't use the square root method because you have a middle term, and you don't want to do the completing the square. Completing the square is hard, and we just did a hard example there a minute ago. So let's use the quadratic formula. Now, the quadratic formula is kind of a shortcut to bypass completing the square. It tells you the solution if you do the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. This is a formula you want to put on your card, so you wouldn't have to memorize it. Now, for this particular problem, a is 1, b is 6, and c is negative 2. Don't forget to put the sign with it. So what we have here is the opposite of b. So we have opposite of 6 plus or minus the square root. Now, b squared is 36. And I'm out of space there. Let me move this to a new location. Hang with me here. Okay, so you have the opposite of b, which is negative 6, plus or minus the square root of b squared, which would be 6 squared minus 4 times a. A is 1. C is minus 2. Don't forget that minus 2. Put some parentheses around it. It'll help. 2 times 1. All right, so gotta simplify what's underneath that radical. Is that 6 squared is 36. That's going to become plus 8. You got to get the signs right. Two negatives make a positive divided by 2. So we end up with the negative 6 plus or minus the square root of 44 divided by 2. Now, that's not quite simplified because there's a perfect square in there. So I'm going to pull out 4 times 11 is 44. So you can pull a 2 out and leave the 11 underneath, and then you can send that 2 into the 6 and make that minus 3. Send the 2, cancels out the 2, and you get the square root of 11. Here's our final answer. This is the one that you actually want to put into the MyMathLab. Negative 3 plus or minus the square root of 11. But remember, you break it up. You go negative 3 plus the square root of 11 and negative 3 minus the square root of 11. All right. Let's do one of these quartics, fourth degree. They're a little tricky looking because, we've just been doing quadratics up to this point. So we could use the quadratic formula, or we could complete the square. We could do some fancy things. Let's use the quadratic formula. I mean, why not? Now, you might be saying, what do you mean the quadratic formula? Well, you use the quadratic formula, but you solve for x squared instead of just plain old x. I'll show you what I mean here. So b is 3, c is negative 10. Here we go. So what we get is x squared. So notice I've got x squared on the left instead of, so this was x equals, in our previous problem, this is x squared equals. And so x squared equals, and then you do the opposite of b, plus or minus the square root of b squared, which is 9, minus 4 times a times c, and all divided by 2 times a. That is negative 3 plus or minus. Now that's a positive 40 plus 9. That's the square root of 49 divided by 2, which is negative 3 plus or minus 7 over 2. This is two answers. This is negative 3 plus 7, which is 4 divided by 2. That's 2. And negative 3 minus 7, which is negative 10 divided by 2, which is minus 5. Now you got to be really careful here. X squared is equal to 2 or minus 5. What? So you got to be careful here. That means that x squared equals 2 or x squared equals minus 5. That means x is plus or minus the square root of 2. This is plus or minus square root of 5i. Okay, be really careful. There are 4 answers to a quartic, and those are all the answers. Let's find the answers here. Plus or minus the square root of 2, plus or minus the square root of 5i. And we just did a really hard one with the quadratic formula. Hey, thanks for watching.